Okay. Good morning. My name is Naoya Arakawa, and the topic of this quick presentation is the issue of information binding, and my proposal will be information binding with associative representations can be done dynamically. Now let me explain why I'm talking of association. First, as a background, let me say subsymbolic information processing such as neural or Bayesian models is important for cognitive modeling. I'll let you, sorry, I'll tell you the reason in the next slide. The point here is technical details of subsymbolic models may obscure certain essences of information processing. So association, and the association can be regarded as the abstraction of subsymbolic information processing. So association could be a right level for talking certain cognitive functions. And this is why I'm talking of association-based of cognitive modeling. Okay, now I explain a bit more why subsymbolic information processing is important for cognitive modeling. First, most functional models of the brain are subsymbolic. So subsymbolic information processing is regarded as biologically natural or realistic cognitive modeling. Second, most modern-day learning models are subsymbolic, and the issue of learning is critical for cognitive modeling. Finally, subsymbolic models fit with non-classical categories demanded by cognitive linguists such as Lakoff. However, associative information processing has its own problems. The first problem is, can dynamic cognitive processes such as planning be explained with association alone? Second, there is the issue of generativity, such as how can syntactic tree structure can be represented with neural models. Lastly, there is the problem of a problem called the binding problem. Here, question is how can an associative system bind spatial or temporal information together, which is the main question in this presentation. So what I'm going to do here is to explain human cognitive functions as associative, to explain human cognitive functions as associative processes, addressing the issue of dynamicity, generativity, and the binding problem. Okay, now my proposal is associative representation is better conceived dynamically as traversal of association path. And I'm going to explain it in the following slides. Now let me talk of information binding. First, in symbolic systems, information is bound by variables so that binding is not an issue. However, if you have to build an information processing system with a subsymbolic representation, which do not use variables, then it becomes an issue, which is the binding problem, as I mentioned earlier. Okay, now I introduce a typical example of the binding problem in scene recognition. Okay, the question is, how does the brain represent the configuration such as, sorry, such as this? Here, if you take only one figure like this, blue circle, there may not be a problem. However, if you have to integrate more than one figure into a scene, then a problem arises. A neural net may have the representation of blue, red, circle, and rectangle. However, how can it represent a scene having various configurations, say blue circle and red triangle, and blue to circle, red to rectangle, respectively? That's the binding problem. Now, the solution part. A solution to the problem would be a system that binds the information together by associating pieces of information dynamically. Here, the network associate the pattern representing blue circle with another pattern representing red triangle with association Q representing relative location. The representation of the red triangle, this entire scene can be represented, retrieved one by one by association. Here, synchronicity is not required, as often mentioned in literature. Okay, binding temporal patterns is dealt with similar way. In this proposal, temporal information is bound by means of associative retrieval of representation. A network can retrieve representation of events with the association Q, like next and previous, one by one by association. Okay, the next slide is planning. Here, representation is similar to temporal patterns explained in the previous slide. Well, planning is the representation of temporal patterns. And plans, and there are plans and subplans, and that subplans are retrieved by associatively, and the plans and subplans make a hierarchy, which is a case of generativity. Okay, the next slide is parsing and natural language understanding. Syntactic structure dealt in parsing is the nested temporal pattern, which is similar to planning explained in the previous slide, and also is a case of generativity. So parsing is also realized with associative retrieval by one. And in semantic analysis here, key association is the association between grammatical function found in syntactic structure, like accusative here, and semantic relation, like theme here. Okay, now let me recap. In this presentation, I explained that information is bound by dynamically associating patterns. And with the use of Q patterns, such as spatial or temporal directions. And the representation here is dynamic by nature, and in case of planning and parsing examples with a hierarchical representation, it was generative. As for future works, I am thinking of doing things like modeling exclusive control mechanisms, experimenting with actual sub-symbolic mechanism with machine learning. Okay, thank you for your attention.
Yeah, I guess we have time for questions. If any questions are there. So if not, so thanks again, and we now go to the next slide.